Hi everyone, Ravi this side. Welcome to Engineering Adda. Today in this video, we are going to discuss about the @async annotation in Spring Boot. So first of all, we are going to discuss what is async annotation, and then after that, we'll try to see what are the uses of async annotation, what are its application, what are the scenarios where we can use the async annotations. Everything we are going to discuss in this video, and after that, practically we'll try to create a Spring Boot application and then see how we can use async annotation in real life. So this is what today's agenda, and let's get started for that. And let me try to go to the next slide, discuss about async annotation first. So in Spring Boot, the async annotation is used to mark a method as asynchronous. Okay, meaning that it will be executed in a separate thread. So in Java or in Spring Boot, we have a main thread. And let's say you have written a logic, or you can say, let's say you have written a couple of lines of code. And when you start executing your code, the main thread will try to execute it out. Okay, but when a block of code is async, that means there would be a separate thread assigned to that block of code, and that thread will try to execute that block of code. And the main thread is not working on that thing. Main thread is working on some other thing concurrently. That means the parallelism is introduced there. That means it is asynchronized, and the time will be reduced, and its effort will be reduced. So that is what it's meaning. Asynchronous meaning that it will be executed in a separate thread. Okay. This annotation enables developers to write non-blocking code, which can be particularly useful for methods that perform long-running tasks such as network operations, database queries, or heavy computations. So these are the long-running tasks. There you can put @async annotations, and then the main thread is not occupied working on those operations, and a separate thread will be assigned to them, and they will be working on that. So our main thread is free, separate thread is working on those operations, and once the result we get from the separate thread, we will try to use that out. But again, the main thread is free as of now. So this is the purpose of async annotation. It will try to give you the parallelism. It will try to asynchronously run your code. So this is what async annotation is, and this is what we can use the async annotation for. Okay. So let me try to again read out these things for you. This annotation enables developer to write non-blocking code, which can be particularly useful for methods that performs long-running tasks such as network operation, database queries, or heavy computations. By executing these tasks asynchronously, the main application thread is not blocked, allowing it to continue processing other tasks concurrently. Okay, so this is the advantage of @async annotation, or you can say this is the uses of @async annotation. Coming to the next slide, here I have listed out the uses of @async annotation. The first one is like you can annotate those piece of codes which are having the long running task. Okay. The second uses is concurrency. It will give you the concurrency. So let me try to brief you about these things. So the first thing that I want to tell you that @async annotation finds its application in scenario where you want to improve the performance and responsiveness of your Spring Boot application. Now the first uses is long running task. When your application need to perform tasks that takes a significant amount of time, such as complex calculation, heavy database queries, or remote API calls, using @async can prevent the main thread from being blocked, ensuring that your application remains responsive. So this is what we have discussed earlier as well, that for the long running tasks, you can use async annotations, and then the separate thread will be assigned to that task, and that will work, and our main thread is free to do the other task. Now the second uses is concurrency. If you have tasks that can be executed independently and concurrently, such as processing multiple requests simultaneously, async allows you to run those or these tasks concurrently, leveraging the available resource more effectively. So if you have the concurrent task, then you can use async annotation there to simultaneously run or parallelly run multiple tasks and use the available resource effectively and reduce the time. Okay. Now coming to the next slide, the third uses is improved scalability. By executing tasks asynchronously, your application can handle more concurrent requests without exhausting its resources, leading to improved scalability and better overall performance. Okay. So when we have a task running concurrently, it will like try to give you the better performance, and it will lead to improved scalability. Coming to the fourth use is responsive user interface. In web application, using async can prevent blocking the main thread when handling HTTP request, resulting in a more responsive user interface and better user experience. Now the last one is batch processing. For batch processing jobs such as data import or export or report generation, async can use to parallelize the processing of the individual item, speeding up the overall execution time. So these are the uses of async annotations, and we have discussed about the async annotation, and then these are the uses of async annotations. Now let me try to come out of it and try to go to IntelliJ and create a Spring Boot application. So we are out of it. Now I already have opened the IntelliJ, and here we are using the IntelliJ Ultimate version. So directly I can create the Spring Boot application here itself. So go to this file, new and project, and here itself you will find the Spring Boot option where you can create a Spring Boot application. If you are not using the IntelliJ Ultimate version, you are using IntelliJ Community version, or you are using some other IDE like Eclipse, then you can go to this site start.spring.io, and there you will find the same page, and there you can create your application and then download it out, extract it, and open up in the IDE that you are using it. So here let me try to provide a name to this application. So it is Async Annotation. Okay, in the Spring Boot. Now go to the Maven. Next, and let me try to use this web and Lombok. Create this, open it in a new tab, and then just wait for a few seconds so that it can download all the dependency that we have added and do the necessary configuration, and then we can do our development here. So just wait for a few seconds, and then after that we can start. Let me try to close this up and go to this, open up, go to the source, main, Java, and here it is. So run this and then try to see how it is behaving. If it is working fine, we can start our development after this. So here what we are going to do is, first of all, without uses of @async annotations, we are going to write couple of codes and then try to see how it is working, and then after that we'll try to use the @async annotation and then show you the performance improvement or the way of working. Okay, so that is what we are going to do here. So here you can see our application is up on the port number 8080. That means our application is working fine. Let me try to stop it, and here what I'm going to do is, let's say when we are discussing about the Spring async annotation uses, or what are the area where we can use @async annotation, we come across that we can use async annotation where the tasks are taking long time, right? such as network operation, database queries, or heavy computations, right? So we are not going to practically do a database queries or do a heavy computation here. What we are going to do is we are simply going to create a couple of services and simply try to print something inside the service. We'll try to create a API and call those services inside that API and then see how they are working without async annotation and with async annotation, so that we can see how the threads are being assigned to the separate task when we are using async annotations and how they are doing the work. Okay, so those things we can see. And if you want to create the scenario, you can use thread slip, so that it can take so much time, or you can say it would take long time for your methods to return something. So those things also you can do when you're going to write the logics. Those things also you can try. But here, first of all, we are simply trying to create 3 services, and then we'll try to call those services inside our API and then see how they are working without async annotation, and then we are going to use the async annotation and then see how they are working. And after that, if we want, if the time permits, we can also try to introduce the slip inside those block of services or block of code, and then see how they are working, how the performance is being improved. So those things also we will try. So let's get started now. Go to the application, and here let's say I'm going to create, first of all, I'm going to create one API. Let's say it is sample controller, and inside this we'll try to create one API. So annotate this with @REST controller, and here let's say I'm going to create a get mapping or get API, you can say. Let's say it is async, or something you can say like get sample, let's say. Okay, now let's say public string get sample, and then return something, let's say sample API. Okay, now let me try to create couple of services here. So let's say I'm going to create the service, let's say network service or something like service 1, service 2, you can say. Or let me try to name it like network service. Network service, let's say other services are database service. And batch service, something like that. So these 3 service classes we have created here. Now let me annotate this classes with @service annotations, and here as well, and here as well. So service. Now what I'm going to do is I'm going to create a method here. Let's say public void display, something like that, and it is simply going to print something inside this. Okay, so let's say as out batch service. Okay, and then we'll also try to log the thread here, which thread is working on this. So let's say thread.current thread.get name, and we are good. Okay, same method we are going to use inside the other services as well, but we are going to update the name. So let's say this is database service, and going to the network service. Let me paste this, let me copy again this display, go to the network service, paste it out, and here let's say it is network service. Copy this, paste it here. So we are good now. Coming to the sample controller, here I'm just going to auto wire those services and private, let's say network service. Similarly, I'm going to auto wire the other two services like database service. And we have batch service, right? So let me try to auto wire that as well. Sorry, where we are. Okay, so we have auto wired all of them. Now inside this, what I'm going to do is call the methods of each services inside this API. So when we are going to trigger that API, we will like one by one we'll try to call the each methods of each service. Okay, so that is what we are going to do. So let's say a network service dot display. Similarly, we have database service dot display, and then we have batch service dot display, and at the end we are returning this sample API. Okay, if you want to remove or you can remove, or if you want to keep, you can keep it, but again you have to return something here. Okay, now let me try to run this application and try to hit this sample API. So I don't know if we can find it here. Okay, so we have this option of endpoint, so here itself we can hit it out. So I'm just going to use that, and not sure if you're getting this or let me cancel this. Hit it out. Let me minimize this endpoint one, and directly what you can do is you can go to the sample controller, and here you can find this option to run it out, open in an HTTP client, and then you can directly hit that API there. Okay, so here you can see that we are getting the response as sample API. That is what we are returning here when we are hitting this API. Now if you'll go to this run option, where it is, yeah, there you will find that your whatever things we have printed here, whatever like services we are calling, we are getting the response for that. So here you can see first of all we are calling the network service, then the database service, and then the batch service, and then we are also printing the thread which is working on that particular service. So you can see that the same thread is working on the three services. Like we don't have any separate threads assigned to the separate services, right? The same thread is working across all the three services. Okay, in that case, let's say if we are going to let's say we are going to the network service here, this time we don't have any sleep, or you can say we are not just delaying this operation. In the second we will get the response here. Okay, but in the real time when you are going to try to develop these methods, try to call a network service or try to do the network operation, there would be so much delay introduced, right? In that case, these operations will take so much of times, and then one by one same thread is going to execute all the services. It will take so much of time, right? So here you can see the same thread is being assigned to all the three services, and if they are going to take times, it will be so much of time that it will take to return the response. If you want to try it out, what you can do is you can introduce the sleep here. Okay, so let me try to do that. So let's say thread.sleep, and let's say we are introducing the sleep of what I would say, let's say 10 seconds. Okay, so it would be in millisecond. I think it is good. Surround by try catch, let's say, and we are going to let it be something like this. So when we are going to run this application and try to hit out, let's say, and then see how much time it is taking. So this is the API we are going to hit. Let's say we are hitted the API, and if we'll go to the run, you see you are not getting anything here until 10 seconds. So once the 10 second is complete, you will get the first response and the second and the third. So that means when the services are taking time, all the other services are also blocked, right? If you want to reduce the delay in the other services, you can notice those things. So let me try to put this piece of code in the other services as well. So let's say go to the batch service and try to put it here, and the same database service, and put it here. Try to run it again and hit the API again. So go to this, try to hit the API. Okay, I think our application, let me try to restart and then try to see. So I'm restarting our application. Our application is up. Let me hit this API. And you can see it is taking time. Okay. Again, here also it is taking time to print out those logs. The first one is taking 10 seconds to print it out, and then after that it will take 10 seconds for the other services to complete. And then after that, again the 10 seconds for the third one to complete. That means it is going one by one in a sequential manner, not in a asequential manner. So when they are taking so much time, all the times are combined together, and it is doing a lot of times to do the real computations. It is taking so much of time to return the response. Here, if you'll go to this where we are seeing those things, or what I can say is, let me try to do one thing again. So what I want to explain here is, when we have introduced the sleep in all the services, then when we are hitting this API, it is going to that particular service, sleeping for 10 seconds, and then the other service is being called. It is again sleeping for the 10 seconds, and then the third service is being called after the 10 seconds. That means all the sleeps, all the times are combined together, producing so much of delay in the API response when we are calling it without async. But this won't happen when you are going to use the async annotation. So let me try to go to the browser and try to hit this API again and then show you. So here you can see we have hit the API. We are not getting any response. After the 30 seconds only we will get the response. Once those logs are printed one by one, then only we will get the response here. And you can see that they are in sequence, like we are in the sequence that we are calling these services, the same sequence they are printing it out here as well. Network database in the batch. So here you can see still we are not getting any response. Now we are getting the response after 30 seconds. So this is what I wanted to show you. Now let me try to use @async annotation in each of the methods from each of the services, and then see how they are performing and what are the threads are being assigned to them. So here we are assigning only one thread to each of the services, to each of the tasks. And there, when we are going to use the @async annotation, the separate threads will be assigned to separate tasks, and parallelly those tasks will be executed. That means they are going to reduce the time. Okay, so response time will be reduced. Now go to the patch service, and let's say we are going to introduce @async here. So async, now database service, @async. Similarly, for the network service, introduce @async. Now go to your main application, and there you have to use another annotation, which is @enable async. Now run your application again and try to hit the API again and then see the response. So let it up and then we can see. So our application is up. Now let me try to hit this API and then show you the response. You can see in fraction of a second we are getting the response here. Sorry, let me try to hit this out. You can see that we are getting the response in the fraction of a second, and here you can see we are printing out the logs. Okay, so first of all, it is calling the database service, which is saying that they are not in sequence. Asequentially, we are assigning this work to the separate threads, and we are getting the response in so much less time. That means our response time is drastically decreased. Now you can see that each of the services are being assigned a separate thread to work on. Like database service is being assigned task 2 thread, batch service is assigned task 3 thread, network service is assigned task 1 thread. That means task 1 thread is working on the network service, task 3 thread is working on the batch service, task 2 thread is working on the database service, and they are working parallelly and they are reducing the time. And again, they are not in the sequence. How we are calling it out? They are asequential. So this is how @async annotation work. It will reduce your response time. It will give you so much of advantage when you are going to write down your code, and basically, like specifically for those piece of code, you can use the @async annotation where there are so much of response time involves. Okay, so this is about the async annotation. If you like the video, please hit the like button. Please subscribe the channel for more such concept. Thanks.